Hey everyone, and welcome back to another video of Boatcraft Electric. And in today's video, we're going to be going over the entire process of the design of our motor mount. So in the last video, we kind of showed how an outboard motor works and took the old power head, which was the 3-cylinder inline engine off, and yeah, that's kind of where we left off. So in today's video, we're going to go over the entire process of designing, prototyping, manufacturing, and assembling the final product here. Okay, so getting into the mounting components needed, we are going to need two main components. So as you can see in front of us here, this is the motor head assembly. So it is an assembly. We'll get into how we came up with that design and why it looks like that later. But one part is this mount that gets the power head strapped to the top of the motor. And then the second part is this little coupling here. And this is what connects the drive shaft here. So that's the spline end here that just fits over like that, right? And connects. And that is going to connect to the axle in the electric motor. And I'm still prototyping this. I made this little notch just a little too big, so it doesn't really fit right now. As you can see, it's not going on, but it would go on like this, and the axle is able to be connected to the drive shaft using this coupling. So those are the two main parts that we had to make, or I guess have to make, are the motor mount and the coupling. So let's go into how we design the motor mount first. Okay, so to understand the design of our motor mount, we obviously need to know how our motor is going to work and what it looks like. So to do this, we need to select a motor that fits our two conditions that we're going to have. So first, we need an electric motor capable of pushing the boat through the water at a significant speed, and this will require the motor to have a pretty significant amount of torque and be able to hold that torque for medium to long periods of time to both get the boat up to speed as well as keeping it at speed and fighting the drag force that will be acting on the boat's hull. So the second condition we need to talk about is safety, specifically safety with electricity. The two main factors at play here are amperage and voltage. And so with high volts, you run the risk of electricity jumping from the wires onto either parts of the boat or, worst case scenario, humans, which would be devastating. It could kill people. With amperage, the threat is that things get very, very, very hot, and in our case, it would be easier to mitigate the risk from amperage versus voltage because of the copious amounts of coolant we have around our boat, aka the seawater. We'll talk about that in a later video about the motor cooling system, but it will be much easier to keep the components cooler when running a lot of amps through them versus insulating and kind of adding a lot of weight to the motor to mitigate the risk of higher voltage. So with these concerns in mind, we chose the Moto Energy 1616 motor, which is a Chinese-made motor, and it is
a liquid-cooled permanent magnet AC motor capable of outputting 55 kilowatts and about 80 foot-pounds of torque. And at max power, it operates around 650 amps and 96 volts.
So a lot of this is kind of just jargon we don't really need right now, and really the only thing from this that we need to design the mount is the 80 foot-pounds of torque. Torque of the motor is very important in this case because it is what's going to determine if the motor mount breaks or not, and we need to be able to design and calculate our designs and be able to determine if the amount of torque is creating too much stress in our design to where it breaks bolts, or even worse, it breaks the mount itself. So keep this 80 foot-pounds of torque in mind. First, we're going to go into how we designed and dimensioned the mounting, and then we're going to go into how we calculated everything. So after many attempts, which it took us this many attempts, as you can see, that's a lot. We finally got our final design here for the motor mounting, and it comes in two parts, and I'll kind of explain this later It'll make sense when it's actually 3D printed out and you can actually look at it. But basically this whole thing, these little holes right here, are what actually holds the electric motor, and those are bolted from down here. And then these smaller holes and these hex holes kind of holds the whole assembly to the motor head. It took us a really long time to get this part was fairly easy to do, mainly because we had the drawing for the motor and it was really easy to get those dimensions. But this part took us a really long time. Honestly, mostly because we didn't have an engineering drawing to go off of for the motor head. So what that meant was we had to do all the dimensioning ourselves, and they were not easy dimensions. They were like falling into something smaller than 64ths of an inch, and it was getting pretty annoying, and it took us a long time to get. So yeah, it had to be pretty precise, because if these holes are a little bit off, they won't line up, obviously, and we can't really just Dremel the holes out and kind of make them bigger, because that will mean it'll break the integrity of this mount. This is meant to be, you know, very fixed. It has this mount has to really fix the motor to the head, and if it's not doing its job, then it's not going to work. So we had to make sure that was pretty precise. And once we got those holes, we extruded this shape. And yeah, this is the shape we got. We ran some stress analysis on this one. This one was a lot easier. We kind of knew that it wouldn't break just from the dimensions. This one was a little we were concerned about, but after running the stress analysis, which I'll show up here, it wasn't actually that bad, and we didn't really have anything to worry about. So yeah, once we got these shapes, we kind of threw them into an assembly, and we are now 3D printing them. I wish I had time-lapsed the drawing process, but I'll just show the engineering drawings later. And as you can see, I'm actually 3D printing that top part of the mount right now. And that'll be done hopefully soon, so we can put this whole thing together and make sure it fits well. And then once we do that, we'll get the parts actually CNC'd out of aluminum, and then we'll have an official motor mount. It should be good. Okay guys, so we're in the garage now, and we're looking at our actual physical assembly of the whole thing, or at least the main part of the motor and what's going to hold it to the base. So over here we have some hardware, as you can see, but here's the actual motor itself. It's a big old 56-pound block of copper. On the right here in the orange, you have the 3 AC phase wires that are delivering power to the motor. Here is the controller for the motor. It's actually more of a sensor for the rotor. And then over here you have the coolant inlet and outlet for the liquid coolant that's going to keep this thing cold while it's running. But to hold it up, here we have 3 printed prototypes. As said before, these will be made into aluminum. We actually have one over here. That's an aluminum block we're getting ready to machine over there. But yeah, so here's the mounting assembly. It comes in 2 parts. We have a middle mount and the base mount. And I'll show you how those go together shortly. We also have a motor coupling. So this little coupling here, as you can probably see, the axle of the motor does not line up with the drive shaft. So to get around that, we made a coupling. So on one side, it's got the same like meshing as the motor axle, which is this little, let's see if we can get it. This little tab right there, and it kind of just, this coupling fits on like that, and it stays nice and loose, or nice and tight on there. And then on that end, that's how the coupling stays on the motor. And on the drive shaft end, we have splined the inside of the coupling, and so it just goes right over the shaft like that, slips down, and now, as you can hear, there's no oil in the lower unit down there, so that's just the gears clanking away. But that is where it attaches there. So yeah, let's just get into putting it together, and we'll put this prototype up on the motor head. All right, so now we have our whole assembly laid out in front of us here. As mentioned before, here is, oops, this actually goes that way. Here is the mount for the motor. This is the base mount, middle mount, all our hardware, and the motor. So this has to be bolted in pretty interestingly, because obviously these mount holes over here, these four, do not line up with the motor, the mount holes on the head of the motor. So had to come up with this kind of strange system. It's not super conventional, but here's how it works. So as you can see, there's some hex heads drilled out in this thing, as well as some other holes. So these three, there's, I don't know if you can see there, these three smaller holes, 1, 2, 3. These are kind of, they're important, but they're not super important. So they have these smaller bolts that kind of hold them on. And those can kind of go on any time, but because a majority of the holes around here are going to be covered by the motor when it goes on like that, they have to be seated before you do anything. So you gotta take 5 of these M7 bolts by, I think they're 60 millimeters long. Just kind of stick them down here before you do anything. Just kind of seat them. And the hex shape is so that you don't have to stick a ratchet down there and make it super hard. Actually, probably impossible. And yeah, just like that, they're all seated. So now you can take the middle mount, kind of put on like that. Then you're gonna take the whole thing and you're gonna flip it over. And these little M7 bolts are maybe going to fall out. Okay, now you gotta make sure you put this thing on right. So how we're gonna orient the motor is all of this stuff is gonna be coming out the back. So this should be on the back. Like all this stuff should be kind of on the back part of the motor. It's also gonna be aligned so that the motor sides, it's gonna be like a box like this. So if this is our motor, it should be kind of turned like this end here is the back of the motor. So we'll plop it down like this. But not so fast, because we have to get these dampeners on. These are rubber bumpers. They're about 1/2 inch high by like, I think it's they're like 1.5 inches wide in diameter. But you kind of just slap these on here, and this is going to help reduce vibration when the motor is running. So when you get above like 50 to 60%, especially with electric motors, what I've seen is that they really do tend to vibrate a lot when they get to higher speeds. And for one guy that I've seen specifically, it was pretty detrimental because he had to, like, I don't know if it was kind of limiting him from getting to top speed because the motor shuts off. So gotta have these rubber dampeners in here. It'll keep the motor from vibrating and shutting off. Okay, so now we kind of, as you saw there, I plopped the mount on top of it, and now we're gonna take 4 5/16 inch bolts. I think they're like 4 inches long. We're just gonna kind of drop them down, and we're gonna just mount the thing. So I have to go one at a time here. Not gonna lie, this is the hardest part of getting this on. Actually, no, I lied. The hardest part is probably lifting it up and putting the 50-pound motor on the actual head. But we'll get there when we get there. There we go, cool. So there's another 1, 2. Cool. So now they're all in there. Push this down. You can see it. And now I'm gonna go slow with the ratchet because I don't want to screw up the threads using a power tool. So, yep, just gonna do this for eternity. I'll probably speed this part of the video up. Everything's kind of coming on here. Alright, get that nice and bolted on there. Cool, and it's solid, so. Okay, so now our mount is sitting up there nice and solid. And yeah, as you can see right here, the dampeners kind of add a little bit of space. Not only are they kind of spacing it out, but they're also making sure that any vibrations are getting a little more dissipated than just going straight into the aluminum. So now you'll watch me do a insane magic trick where I flip this and put it on its head onto the motor. And I've taken the outside cowling parts off just so that you can see what's going on a little bit easier. Wow, that was the quickest I've ever done that. That just goes on real good. All right, so now this would be a time when you start putting the nuts on the other side, but I'll skip that part. This is more temporary than a demonstration. But now we're gonna install these over here. Just put these suckers over there. And luckily, right here would be kind of tough to get that, but well, maybe I didn't do this. I did not dimension this right. Oh well, I'll fix that. Yeah, I'll put all these in, and that's kind of how it sits up here. This is the real thing right here. Here it is. So it'll be mounted up just like that, and that is where a bulk of the project lies. Back here will be where the motor controller goes, with all the wires and stuff. And the coolant is gonna be kind of funky. We'll cover it in a later video. It's actually gonna run up to the front here and kind of do a lap around here and actually enter from the pit of despair down there. We're gonna put a big old electric pump down there. That's gonna pump water up from this opening right there. I kind of have the inlet off, as you can see right here. There's actually supposed to be a nice grate that goes over this. But water gets sucked up here, goes up through the motor, gets pumped up, and then will come up around here. And we'll cover that in a later video, but this is what it looks like once it's mounted. So now let's go start machining this aluminum right here. Okay, so the first part of machining is gonna be actually kind of drilling this circular part out and replicating the middle mount that was here. So to do that first, we gotta measure out all the holes, you know, the center hole, the mounting holes, all that stuff. So what I actually did was, you know, measuring can be a little sketchy, especially with circles, can be a little hard. So I just figured, well, I'll just take my already existing design that I have and make a stencil out of it. So basically this thing fits like a glove. This one didn't fit like a glove. It's a little too wide, but this is the idea. It has some edges here, as you can see, and it just slips over the piece of aluminum like this. Fits real nice and tight, so it's not going anywhere. And I marked all of my holes that I'm gonna cut in orange Sharpie. And then when I'm ready to cut, my friend Blake and I were gonna pop this thing off and head over. And the first cut we're gonna make is the 2-inch hole that needs to be drilled right in the middle of this thing. And to do that, we'll be using, it's kind of a mess over here, sorry about that. we're gonna be using our drill press with the 2-inch bimetal bit that we have, and hopefully that does the trick. So we'll do that right now. Okay, so here we are. Now I took the prototype apart because I'm kind of measuring up, so I was measuring up some holes here, but now we are starting to machine the middle mount. So we might cut some parts out later with the CNC, just cut some shapes out. But for now, we just have this circular block of aluminum. I think it's about 1.5 inches thick, and it has a 7-inch diameter. And then here are the mounting holes that we cut into it previously, and we lined it up. It fits with the motor. So now I'm going through the very tedious and very, very loud process of drilling out a 3-inch hole in the middle of it where the drive shaft will go. So this is gonna take a while. Maybe I'll try to time lapse it right now. I'll probably end up skipping it though, because it's just gonna be me going back and forth with this thing, and it's probably gonna take a while. So here's kind of what it looks like right now. You can see the hole saw here has started working. That trench is about maybe a 1/4 to 1/2 inch deep, and I got probably 1 inch more to go. So I will show you guys what it looks like when it's done and when I pop this thing out the back of it. All right, go for it. Pop, is it stuck? Heck yeah, look at that. Yeah, it's okay. It can be a little off.
Yeah.
We just need a hole. That's really all we need.
Need a hole.
Just need a
Get
hole.
yourself a hole.
Yep, there we go. A ton of mess later, and there is the middle mount. And now we're gonna manufacture the bottom mount. All right, so we're measuring everything up here on the mount, and unfortunately, one of our holes was just a tiny bit off. Everything else fits perfectly, but this one, if you can see, I don't know if you can tell there, so I'll drop it. If you see there, it's just a tiny bit off. So we're gonna kind of try to open this hole up a little bit and see if that fixes the problem. I go again.
They call me the reaming expert.
How's that looking?
Yeah.
Did it do anything?
Yeah. She's reaming.
Fuck yeah.
She's reaming.
All right. Go. Oh yeah. Yeah. Oh yeah, it's looking a little better.
Test it.
All right, it's a little tight, but we fixed the hole and this thing does mount pretty well now. So now that we got this, as I said, we're gonna go over and do the next piece of metal and then put the whole thing together and put it on top of the motor head. So let's go do that. Okay, so after some more machining and a new design, here is what the middle part of the mounting looks like. So these holes here will connect the two mounting plates together, and then these holes that we kind of bored out a little bit will actually directly connect to the motor. So that's just what it looks like before we put it on. Okay, so after some machining and changing of ideas, here is the finished bottom mount for the motor. So last night we finished the middle one, which is nice and snug on there now. And we just finished drilling all the holes for here. And we have a little bit of a design change that I'll talk about later, and you might be able to see it. These hex heads, or these hex bolts, are not gonna be countersunk into here, because that's just too much room for error on like everyone's part, both our part machining it and on the part of someone who'd want to maintain it in the future. So we're actually just going to end up putting spacers in between these two plates, and yeah, just like so. And this shouldn't add too much to the shear stress in the bolts that are holding this thing on. We're gonna run some calculations. If it is too much shear stress, we'll just double up the bolts. So instead of having 4 bolts holding it on, we'll have 8 bolts holding the 2 plates together. But yeah, we're gonna go ahead and put this thing together and see what it looks like. All right, so we finally finished the mount for this thing. So as you can see, it's got 2 parts here, just like our prototype did. It's a lot more simple because it's just 2 circles, but the prototypes were gonna be either really expensive to machine or really hard to machine. So we just went with this design, which will work just fine. As you can see, it's got 2 sets of like dampening layers, so the vibrations from the motor won't mess up the actual body of the outboard motor or the boat when it's at full power. And yeah, this is what it looks like. It's all nice and shiny. We'll drop it in probably when we get the actual metal part for this, and then after that the mount will be complete and we will never have to touch it again. Yippee! Okay, and after all of that, we are completely done with the mount. As I said, I have to get one of these coupling parts specially manufactured because it's a little out of our reach for what we can do, but that's okay. We'll get that later and I kind of won't worry about it too much. This is the main part that was going to be probably the most heavy duty in terms of manufacturing. We might try to get it CNC down to a shape that closer resembles its prototype. But this works for now, and this will probably work as the final design. So yeah, that's all for this video. This is the finished mount. You'll probably see us mount it later when we get this part finished. And most likely our next video is either going to be on the electrical system and starting to do that with the motor controller, or it's going to be on the coolant system and how we're going to do pumps and heat exchangers. And actually, speaking of heat exchangers, I actually bought one for this project. This is the official heat exchanger we're going to use, and we'll kind of talk about how this works and why we need it in the next video or the video after that. But this is one part of the coolant system, and it is mainly used as kind of like a radiator for the motor. So where a car has a radiator for the engine to cool off the engine coolant, this boat has a heat exchanger to cool off the coolant for the motor. So that's the main idea. We'll get into that in the next video, but yeah, I got this thing on sale. It's pretty cool. 24 plates of copper, very good at exchanging heat, and it should work good. Anyways, that's the end of the video. I hope you enjoyed watching us build this thing from kind of start to finish, from the design process and how we 3D printed everything to how we actually got this thing made out of real life aluminum. In future videos, I'll probably try to add more of the actual CADing process and our brainstorming. I realized I didn't really do a great job at filming that. It did take us a few months, especially with school starting back up in the fall here. We got a little behind on that. So for the next videos, I'll try to give you guys some insight into what it's like to plan this thing and really get a better picture of what it's like to do these things from start to finish. But that's all for today. I hope you guys enjoyed the video, and I can't wait to see you guys next time.